Alright guys, so welcome back. This video I will try to explain again about the data generator that we just did in the last video. So in the last video, what we did is we create a read function. Actually, let me try to explain YOLO first. So YOLO is that the YOLO works in, so it splits the image into grids. So that, for example, in here it's 3 grids. So 3 by 3 grids. And for each grid, it's gonna predict a label. So a label. So for my order, what I did in the video, in the last video, is that I do X, Y, W, H, the confidence, and the class. And that's what I did in the last video. So, and so this first 5 elements is called a bounding box. So in the original paper, they use 2 bounding boxes. But in this series, I will only use one bounding box only, so that we're gonna feel it easier to implement the YOLO laws and understand it and see how it's perform. And later we can try to improve it by adding more bounding boxes. And that's it. So coming back, so for example, this image, each will be responsible for predicting X is the midpoint, and W and H is the width and the height of the bounding box. So this midpoint is relative to the cell only. So for example, if I have it like this, the midpoint, then if it's relative to the image, if it's relative to the image, it's gonna be something like 0.5 and 0.5. Okay, but now we're trying to take it relative to the cell only. Yeah, so that's what I mean by relative to the cell. Is you're making it relative to the cell, not relative to the whole image. Okay, so yeah, the way we make it relative to the cell is pretty straightforward. I already did it in the code. Is that you're taking the integer of the grid size times the actual X, which can return the integer of 0, 1, 2 to the grid size, and then you're taking the float of it, so grid size times X and minus that, so you're gonna get this from 0 to 1. This also from 0, 0 point something, and 1, 1 point something. So it's like a float, okay? So taking a float, you minus it by the integer, and you got this value range, okay? That's how we make it relative to the cell. All right. Next is, so that's, to summarize, I will try to say it one more time, is that, for example, in this case, the midpoint should be here, and the bounding box is over here. Yeah, so you're gonna be predicting the width and the height and the X relative to the cell, X and Y, okay, relative to the cell. So our output gonna be our label, the truth, gonna be X, Y, W, H, confidence, class 1 and class 2. Yep, that's what we have. And this is something we already did, already implemented in part 2. So yeah, this is just like a clarification video so that all of us gonna understand the YOLO architectures. Is that first it's splitting the image into grids, then it's predicting that, and that's how YOLO works. It stands for you only looks once. Okay, so now we come to the model architectures. So as I said, it's a really simple implementation, and we want to see the best performance. So in this case, in order to make it more simple, we're gonna use a pre-trained model, and then we're having some fully connected layer, and then reshaping it to the grid side. Okay, so first what is our output? What is the label matrix for one image? So first we input one image of the shape of, for example, 224 by 224 by 3, right? So that's 3 of them. So after our model, we have the output, and our output gonna be like this. It's gonna be a grid size. For example, in this case, it's gonna be a 3 by 3 grid size. Okay, and each of them gonna contains 5 coordinate confidence, right? And then we plus the class. So let me see, how can I say this? So it's really gonna have 5 times the box size, box number, plus the class number, okay? And the box number, why 5 times box number, is that there are X, Y, W, H, and a confidence score. So all of them are gonna be 5. Yep, so it's gonna be, in this case, gonna be 7, okay? And this is 3 by 3, okay? 3 by 3. So its output is gonna be 3 by 3 by 7, okay? That's our output, okay? So when we try to create a model, this is what we're gonna do, create a model using the Tensorflow framework. First, we're gonna have the feature extractors, okay? In this case, I'm gonna use ResNet 50 so that we don't need to trying to replicate the whole model again, the whole darknet model again. We can either use to train this model again, or maybe just use the default weight, which is trained using the ImageNet. After that, we got the output. In this output, we're gonna use a fully connected layer, okay? And after this fully connected layer, the last, this is for classification detection, okay? Like for detection. And lastly, a last dense layer is gonna have a dense layer of this one, but you flatten them, so 3 times 3 times 7, okay? So why I do this, for example, if this is 3 is 9, 9 times 6, 7 is 63, right? So 63. And finally, you reshape them into a grid. You can do like this. So reshape 3 by 3 by 7. And TensorFlow has this layer, so yep, that's how it's work. And then we can just do our Yolo loss, okay? Model architectures. Okay, I would say that's it for this small part, and then we're gonna go to start implementing this model, okay? Okay, we're not following this pipeline. Okay, thank you.